Hi guys, we're back in town. So for those of you who've not yet started circles, I know some of you have. Those of you who've been away for a while, I don't know where you are in this. Let's just rotate a bit. Okay, I'm here. So if you can see the screen there, then this will remind you about circumferences and circles. I did mention this in the previous video. Let's just wind on. A couple of demos from question 1 and 2. What you can do is just pause the video and record them as demos if you're not sure and you need some revision from year 8. So if you just grab that should be fine. And so again, we say pause the video, make the screen large so you can see what's going on, and when you're ready, just wind on. So let me just wind on myself because I'm ready to move on. I did say do semicircles as well. This is, I think, it looks like question 1A on page 185. I've demoed how to do the area. This is really easy. Well, you know the area of a whole circle is pi r squared, and there it is, and the radius is clearly 14 centimeters, so pi times 14 squared gives us that. It's only a semicircle, so don't forget to divide by 2, and there's your answer for the area of that shape just there, that semicircle. Now to do the perimeter, we need to work out the circumference of the entire circle. So here it is, c equals 2 pi r, there's your answer. But the length of the semicircular arc, that which I've highlighted in yellow, is going to be the whole circumference divided by 2, which is 43.95, which is why I put it back on the diagram up there. So 43.95 is a semicircular arc just there. And don't forget, for a full perimeter, we'll go around the arc, then across the base as well. And these are two 14s, since 14 is a radius. Don't forget to add on the 28. So here it is down here, 43.95 plus the 28, and that is the full perimeter of that shape. Let's wind on again. Stop the video right now and take those notes, then you'll have confidence to do the others yourself. Here's one of these quarter circles. I've blown it up a little bit big, and this is question 2A of the same exercise. The easy part is work out the area of an entire circle, pi r squared, and don't forget to divide by 4. This is only a quarter of a circle, and that is a right angle. Okay. Now in terms of the perimeter, here's a perimeter, 4.2 plus the length of the quarter arc plus another 4.2. So 2 pi r, 2 times pi times 4.2, that's a whole circle. Divide by 4, and that will give us the length of this arc here, which is 6.6 centimeters. Don't forget, like I said a few seconds ago, the perimeter will be 4.2 plus this 6.6 right there, plus another 4.2 to take us back home, and that should come to about 15 thereabouts centimeters around that shape. What's next? Composite shapes. Well, I've not set up too many of these. Oh, there's one. It's not very tidy though. I don't like it. I might do another live question. Oh, let's just do that one. This is exercise 6, page 187. If I go to the camera at this point now, I'll show you exactly what I'd like done for those of you who are waiting for this part. So I'm calling up the camera. I'm sure I've clicked it. Here she is. So here we go. Like I've told many of you in class who are onto this, exercise 6, page 187. So you do 1A, 1C, 2A, 2C, 3A, 3C, and these are the year 9 extension questions, 4A, 4C, 5A, 5C. Let's try and sharpen that up a little bit. Not bad. So that's it. So just to talk you through it briefly, we have a square. Actually, we call that a trapezium. It's a lot easier to call that a trapezium. Yeah, we've got the base, top and bottom, and the height. So we want to work out the perimeter and the area of that shape. So we've got a trapezium, and just add up the distance around the edge of the shape. Here we've got a rectangle with a triangle on top. Work out the two parts and add it up. Of course, the perimeter is quite easy. 10.6, 3.9, 5.1, 8.8, and that little part's got to be an extra 3.9 because that's a rectangular bottom there. Here we have a triangle sitting on top of a parallelogram, and ditto over here, a triangle sitting underneath the parallelogram. here, I'm just briefly talking you through it, it's easy to do. Here we have a rectangle which is 4.2 by 6.2, and here we have a semicircle of radius 2.1. Work out the area of each part and add it up, and then you just work out the perimeter of the whole thing. Remember, this is the perimeter of a semicircle, so when you work out the whole circle, don't forget to divide by 2 to get that semicircular arc like we did before with the circle questions. So 3A, 3C, and this is a triangle stuck to a semicircle. That's another triangle stuck to a semicircle, and that's some sort of gremlin thing. 5A, let me talk you through it. We've done trapezia before. Area of a trapezium is half bracket A plus B close bracket times height. So we can work out the area of that trapezium quite easily, and the area of the top semicircle, and add up the 2 bits. So it's just 5A and 5C. What else have we got? I think I'll let the video run for a bit. This is volumes of shapes. Again, it will be the area of the top part multiplied by 11, and that will be in centimetre cubed. This is a triangular face at the front here, so the volume of this prism will be the area of this triangle given to us multiplied by 19, and that will be in metres cubed. Don't bother with volumes of cuboids, that's year 7 work. Over here, which is where I think some of you are sitting at the moment, there's quite a lot of them, and let me just talk you through a couple of them. Over here we've got again a triangular face, so that will be 4 times 7 divided by 2. Get your answer, and then multiply by 10, and that will give you the volume of that. Refocus. That will give you the volume of that prism right there. Here we've got a radius of 6 and a height of 12. So I'll just demo that one briefly over here. If I've got a cylinder, say R equals 6 centimeters and a height of 12 centimeters, you may recall that the volume is going to be pi r squared. Well, that's the top area multiplied by h. If you use this as a GCSE thing, you're just substituting pi, 3.1 is good enough, 6 squared times 12, put it into your machine and get an answer in centimeters cubed. Is that alright? That's all there is to that one. Watch out for this one, it's worth doing. That's a diameter, so don't forget to divide by 2 and use radius of 7. That's the same one as one of these, except that it's facing around the other way. This will be the base, this will be the height. So you do half base times height, then multiply by 28, and that will give you a volume in millimeters cubed. Look at this one, for example. We've got a very clear trapezium. There's your A, there's your B, there's your H. So your volume will look a little bit like this. If I can just do it here. We've got the area is going to be half of, what's that, 9? Yeah, 9 plus 11, close bracket, multiplied by a height of 5. Get your answer, and then multiply by the depth of 12. When you get that, that gives you a volume in centimeters cubes. Okay, some of you I know want to do it in one step. We go half A plus B times H, and then you could of course multiply by 12 in one step. That's totally acceptable for GCSE grade 4. Alright, so if you want to extend beyond this, there's a few word problems that's so worth it. I recommend at least question 12. It's lovely. If you do it, try and draw it, just do it. And I'll probably put up another video quite soon, because some of you need to talk about surface areas. So I'll stop it so it doesn't get too long and upload this, and I'll call this Wednesday's lesson, and that will be due for, I guess, Thursday. And then I'll be communicating with you after the Easter break. Of course, I'm not going to stop you from going forward in the book, because that's a good thing to do, isn't it? So let me just cool this down a little bit and reduce it and stop the vid.